Hello, welcome to my channel, and today I will continue with the series which are for more advanced topics, and today I will talk for something really interesting. We will integrate Redis. So the problem is how we can handle concurrency in FastAPI. We will create logs for APScheduler and Firestore. So what that means? We have the FastAPI application and we can have, for example, multiple workers or multiple instances of this FastAPI application, and since we have APScheduler job which are triggered by Cron job, so if we have more than one worker and more than one instance, we will execute more than one same job. So to be sure that we will execute only one job, we have to create a log, and this log will provide us the possibility to execute only one APScheduler job. For that we will use Redis log. Similar, I will show after a moment an interesting issue with NoSQL databases, in this case Firestore, where we will be able to create more than one user with the same email, even if we make a check is that email existing or not. So for that I will use again Redis log. Let's continue with the overview of the problem. Hello, welcome to Advanced Series. Today I will describe two more problems. I will describe two because I will fix them with one tool. So let me first describe the problems. Here I wrote one more job, which is asynchronous job for the async scheduler, where I will await asynchronously 1 second and I will print hey, and I am adding this function and I am adding interval trigger for 10 seconds. Okay, let me clear, and I want to start the application with 4 workers. As you can see, scheduler is created for all the 4 instances, for all the 4 workers, and you can see we already have the message hey 4 times. So if we start to execute this round end logic, we will execute it 4 times. So if we have, for example, 16 workers, what we will have? I think you will get this. We will have 60 times printing of hey. Okay, this is the first problem. And the second problem, I will open register, user register. Usually when we register a user, we check is that user already registered. And then we raise email is already registered, if we have it. If not, we hash the password and we are adding this user. But since this is no SQL database, Firestore is no SQL database, we can't write constraints in NoSQL database. Usually in relational databases, SQL databases, for example with MySQL or PostgreSQL, we can add constraint. Okay, we will have only one unique email per table. And if we try to, even if we don't check before to add the new user, we will receive a database error. The database will not allow us to add this. Okay, but how we will handle, where is the problem? Still we are selecting the user. Okay, so let me show you. Okay, so for example, I'm registering some user. Test, and let me say times 02 because I already have times 01. I will write the password, I will confirm the password. Okay, and right now I disabled the waiting time for register. What I mean, usually I wrote the front-end logic when I click register this button until the response is returned to be disabled. But let's say I didn't implement this in the front-end. I start to click very fast. Okay, what we have here? You can see we have 3 BET requests. Let me stop the application for a moment to see the logs because they are interesting. We have 4 created requests and 3 BET requests. And let's check what's happening in the database itself. Okay, let me change this query. We can see we have 4 times this email. So this is the second problem. We can create more than one user with NoSQL database. We have something called race condition. Until the operation is done, we can receive post requests for the same operation. So here we have to create some logic which handle this scenario. And we have to handle for all workers because we can have, for example, 16, 20, 30 workers, or we can deploy this application in Kubernetes with many instances in different places. So we have to create some logic. Okay, so this is the brief description of the 2 problems. And let's overview the solution. I made few changes and let me show you. First, I created a one file, Redis logic, you can call it whatever you want. And here I imported Redis from AsynQ. Since I'm using asynchronous programming with FastAPI, I want asynchronous Redis client. You can see this object is creating asynchronous client. And we connect this Redis to my local host. I started a container of Redis on my local machine. If you want me to explain more in details how we can do it, I will explain it in separate video. Just write me a comment. And here I have 2 functions. One is the acquire lock, which is important function. And I'm using async context manager from context lib. Since I will use this function as a context. And here what I have, the lock key which I will use, and acquiring the lock. Here I don't pretend that this is the best solution, I wrote it really fast. Definitely maybe it can be refactored and to be better, but this code is working. So I'm creating the lock and I'm trying to acquire the lock here with lock.acquire. From Redis client I'm creating the lock and acquiring the lock with await, since this is a synchronous function. You can see it from here, async def. And I'm trying, if the lock is acquired, I will yield the function, the functionality which is in the context. Else I will raise an exception. This walk is already acquired. And finally, here I am releasing the walk. And here I just wrote a high order function to create a walk for jobs. And here I'm taking the walk key, the function, and I can give some expiration, but I added default 30. And here I'm returning an asynchronous function which is trying to acquire the walk, and if, as I mentioned, the walk is acquired, we will await the function. If not, we will accept the exception, but I will pass it since I don't want any error messages or something like this. Here you can print the exception if you want, or you can make other functionality. And here in the async job scheduler, I just wrap. You can see I wrapped only one of the functions, which is the interval trigger, which is on 10 seconds. Actually, we have to provide some key, whatever key we want, and let me show you. I will start the Cron with more than one worker. I will start with 8 workers. Okay, and let's wait to see what's happening. You can see we have only one message for hey, not 8. Because we created the walk, only one job was created the walk successfully, and only this function executed its logic and printed hey. Okay, this is the first problem and the solution. And let me continue with the next problem. Let's try to create more than one user with the same email. Some user 01 example.com. Okay, let me write the password and confirm that password. Okay, so here is the moment to look carefully here on the console. I will click really fast. You can see we have executed, we have created many requests to this user's register with the same data. And you can see we have, let me open in the file, almost all of them have a conflict and only one successfully created the user. And let me explain the logic. Let me open this on the right just to take a look. So here is the route we are trying to post. And I am using here try except, since here I want to raise an exception if the walk is acquired. And here is the logic. Asynchronous with acquire walk and user data email. So here I'm using user data.email, the email of the user as the key for the walk. And if this function successfully create the walk, this function will start to select do we have an user, and if we have an user we will raise another exception. We will execute the existing logic and we will create the user and we will return user. But if this walk is already acquired and there is the same post request with the same user email, since this is used as a key, the logic will be not able to acquire the lock, and it will raise exception. And here we are handling the exception and returning 409 HTTP status. Okay, thank you for the attention.